All right, hey guys, welcome back. We're still in our trig packet, and today we're going to be taking a look at page 5. Now, page 5 is going to be tricky because you're going to have to take into account all the concepts that you've learned on the first 4 pages, and you're going to have to apply all of them to these graphs. All right, so let's get to it. So the directions here ask us to determine the amplitude, frequency, and period for each of the following, and then we have to graph them on the set of axes below. All right, so what I'd like you to do is take a look at number 1 and think about what you learned in the last videos, okay? The last couple videos, when you look at an equation, what do these numbers represent? And, think about some formulas you learned, and I'd like to see if on your own you can find these 3 things. Okay, so hit pause and do that. All right, so let's see how you did. So we know that by looking at an equation, right? This number in front of the word sine is going to tell us the amplitude. So here our amplitude is equal to 3. Okay, now the number that's in front of the x, right here, okay, it's after the sign, it's in front of the x. This represents our frequency. So our frequency is 1/2. Okay, so now when we look at an equation, right, none of these numbers come right out and say, oh, this is our period. But what we do know is we know a formula for period. We know that period is equal to 2 pi over the frequency. All right, so let's use this formula. So this is going to be equal to 2 pi over, well, we just said up here that the frequency is 1/2. So I'm going to put a 1/2 on the bottom of this fraction. Okay, so now whenever you have a fraction within a fraction, all right, I know Ms. Carter went over this in the last video. What we can do, we call this keep, change, flip, but basically what you're doing is you're multiplying the top and bottom by the reciprocal of the denominator. So the reciprocal of 1/2 is 2/1. So what we're going to do is we're going to multiply the top and bottom of this fraction by 2/1. And the reason we do that is because that gets rid of our denominator down here. 1/2 times 2/1, these just cancel each other out because doesn't this 2 on the top cancel off with this 2 on the bottom? Okay, so that just cancels off. So technically we have a 1 left in our denominator, and we know that anything divided by 1 is just itself. So we could ignore this. So basically what we're doing here is 2 pi times 2/1. Okay, so this is a 2 pi over 1 times 2/1. So if we multiply the numerators, 2 pi times 2 is 4 pi. And then if we multiply the denominators, 1 times 1 is 1. But I'm not going to put that 4 pi over 1. I'm going to leave it as 4 pi. All right, so now we know our period, our frequency, and our amplitude. And we're going to use these to help us graph this function. All right, now, before we graph, what's really important is this right here. They want us to graph it on the domain, so on the x-axis, okay, on the x values, where x is between negative 2 pi and positive 2 pi. So we're going to have to number all the way up to 2 pi and all the way back to negative 2 pi. And it's really important to follow this domain because if you look, like, see below here, this gives us a totally different domain to graph on. So it's really important to graph on whatever domain they give us. All right, so now if you recall from the last videos, when we go to number our x-axis, we're going to first, this is 0, right? The origin is 0. And then we're going to number pi over 2, pi, 3 pi over 2, and 2 pi. And it's really important that you become familiar with those, okay? I know Ms. Carter went over how pi over 2 represents 90 degrees and how pi represents 180. So I'm not going to go back through that, but you want to label your x-axis accordingly. Okay, so, and what I did, it's really important to skip a box in between each of your labels because sometimes you're going to need to use that halfway point. And you'll see as we do more of these, okay? So in the positive direction, pi over 2, pi, 3 pi over 2, and 2 pi. And I just skipped a box in between each label. And then as I worked in the reverse order, I just put the negatives of each of these. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, so now let's go ahead and number our y-axis. Now you could do one of a couple things. Now, since our amplitude is 3, right? You could just number this like 1, 2, 3. Or if you want to skip boxes, you could skip a box and put 1 right here, and skip another box and put 2 right here, and skip another box and put 3 right there. And then you'd be using the entire height of the graph. Because remember, if the amplitude is 3, we're going to be going up to positive 3 and down to negative 3. And I want to say for now, because we're going to learn that's not always the case as we really progress into the back end. But for right now, for the beginning purposes, this amplitude is going to tell us how high and how low we're going to go. Okay, so you could see here, I decided to jump boxes. Okay, but you didn't have to. Okay, now in order to graph this, let's think about what our just basic y equals sine of x looks like. Okay, this is one complete cycle of our just basic sine curve. Now, if we look here, we know the amplitude is 3. So what that tells us is that our graph here is going to go up to positive 3 and down to negative 3. Okay, let's go down the list. Now, frequency is 1/2. If you recall, and you could feel free to look back in the packet at the definition, but the frequency is the number of complete cycles between 0 and 2 pi. So what that means is we're only fitting a half a cycle between 0 and 2 pi. So if this is a full sine curve, what that means is we're only fitting half of this curve between 0 and 2 pi. Okay, so I'm going to stop for a minute. I'm going to come over to my graph over here. Because at this point, this is going to help us start to graph this. So between 0 and 2 pi, we're going to fit half of this sine curve. So it's going to look something like this. Right? Now let's plot these points exactly. So we know that at 0, we're at a height of 0. And since we're only fitting half of the curve between 0 and 2 pi, at 2 pi, we're also at a height of 0. So I'm going to put a point right here at 0, 0, and another point right here at 2 pi 0. Okay, now, halfway between these 2 points, isn't our graph up here at a maximum? So let's think about the x-axis. Where on the x-axis would that maximum occur? What would occur halfway between 0 and 2 pi? So what's halfway between 0 and 2 pi? Halfway between them would be pi. So I'm just going to put that here for now. So at pi, we're going to be up here at our maximum of 3. So let's put that on our graph over here. At pi, we're going to be up at our maximum of 3. Okay, so from 0 to 2 pi, I mean these are really the only 3 points that we're going to be plotting, okay? At pi over 2 and at 3 pi over 2, we don't know what those exact values are going to be, but we do know that starting when x equals 0, right, our graph is going to increase and increase and increase until it reaches a maximum of 3, and then it's going to come back down. Now, make sure you do not make your graph pointy, okay? This should be a curve. It's called a sine curve. All right, so let me connect these like that. Okay, now, let's think about this. Now, we also have to go in the negative direction. Now, we know that a sine curve, right, it just keeps going and going. That's what happens with the sine curve. It could just keep going. And if we were to go in the opposite direction from here, as we're working left, our way left, wouldn't this come down and then back up? Okay, so if I start here, right, I'm gonna work my way to the left. I'm coming up to this maximum, then I'm coming back down to 0. Now, if I kept going, wouldn't I eventually come back down to a minimum and then back up to 0? Now, let's think about it. To get from a height of 0 to the next height of 0, it took me 2 pi units. So if I was working in the reverse direction, wouldn't it take me 2 pi units to get from here to here, right? So when I'm at negative 2 pi, that's when I'm going to be back at a height of 0. So at negative 2 pi, I'm going to put a point at 0. Now, just like halfway between this point and this point, we were at a maximum. if we're working this way, halfway between these 2 points, which is at negative pi, we're going to be down here at our minimum of negative 3. So let's put a point right there at negative pi, negative 3. Okay, and then let's just curve those together. And this is the graph of y equals 3 sine of 1/2 x. So let's make sure we label that. So you can see, I mean, there's a lot that goes into these. There's a lot you have to think of, and these are tricky. So, you know, after we do these examples together, you may want to take out a piece of paper and try these again on your own. Okay, the more you practice these, the better you will get. All right, so now let's take a look at the next one, number 2. And we're going to do the same thing for all of these. I mean, if you want to try number 2 on your own, that would be awesome. That way you could see, you know, whether you're getting the hang of it or not. So hit pause and try it out. Okay, so now this time we could see that the amplitude is equal to 4, right? That's the number in front of the word cosine. And then the frequency is the number that comes right before the x, or right after the word cosine. So there's a really 1, there's a 1 in there, right? 1x. So our frequency is 1. And we can't tell the period by looking at the equation, but we do know that the period is equal to 2 pi over the frequency. All right, well, since we just said that the frequency is equal to 1, that's equal to 2 pi over 1, which simplifies to 2 pi. Okay, so now based on everything we have here, let's graph this function on the domain from 0 to pi. So now we're only numbering from 0 to pi. So I'm going to skip 2 boxes, and I'm going to label that pi over 2. And then I'm going to skip 2 more boxes and label that pi. So it's going to be a small graph. It's only going to go from here to here. All right, now let's think about the height of our graph. Now for right now, the amplitude is telling us how high and how low we're going to go, because the amplitude is the height from the midline. In this case, our midline is our x-axis. So it means we're going to go 4 units above the x-axis and 4 units below the x-axis. So to fit this on here, I'm not going to be able to skip boxes. So I'm just going to do this. Rather than trying to squeeze in all those numbers, I'm going to jump up 1, 2, 3, 4 boxes, and I'm just going to put a 4 right there. That's implied that this is 1, this is 2, this is 3, and so on. Okay, I'm going to do the same thing. I'm going to jump 4 boxes down, and I'm going to number that -4. Okay, so before we get started with graphing this, let's just think about what our basic cosine curve looks like. So here's my x and y axis, and my basic cosine curve looks something like that. Okay, so since the amplitude is 4, we already said it's going to go up to a height of 4 and down to -4. Okay, also, the frequency is 1. The frequency is the number of complete cycles between 0 and 2 pi. So that means we're going to fit 1 complete cycle. So here's 1 complete cycle between 0 and 2 pi. So when we get to the end over here, we're going to be at 2 pi. But here's the deal. We're only graphing to pi. We don't want to go all the way out to 2 pi. So if this is where 2 pi is, right, wouldn't halfway between 0 and 2 pi be where pi is? So wouldn't pi be at this halfway mark right here? So really, we're only going to be graphing, we're only going to see the first half of this graph from 0 to pi. So this is what it's going to look like on our graph here. All right, so let's think about how this is going to work. So a cosine curve starts off at the maximum. So we're going to be at a maximum height of 4 when x is equal to 0. So let's put a point at 0, 4. Okay, now let me jump over here. At pi, we're going to be all the way down here at our minimum of -4. So at pi, let's put a point down here at -4. Now we know halfway between the maximum and the minimum, we're going to be at a height of 0. Now let's think about this. If the maximum occurred when x equals 0, and the minimum occurred when x is equal to pi, what's halfway between 0 and pi? Well, look, you can see it here. Halfway between 0 and pi is pi over 2. So at pi over 2, we're going to be at a height of 0. We're going to be on that x-axis. So let's put a point right there. And remember, this is a curve, okay? What I don't want you doing is this. I don't want you making a straight line, okay? That's not what we have here. What we have is we have a curve. So it's going to look something like that, okay? And then you can just label it with the equation. So y equals 4 cosine of x. One other thing I wanted to point out, and I should have done this with the first example as well. See how it says the period is 2 pi? The period is how long it takes to complete one cycle. So see, if we were to have graphed this entire cycle, wouldn't that have taken us to 2 pi units? Okay, and let me go back to number 1 for a minute. Let me scroll back up here. Okay, with this one, it says the period is equal to 4 pi. Now, between 0 and 2 pi, we're only fitting half of the curve. So if we wanted to fit the other half of the curve, wouldn't we have had to keep going until we got to 4 pi? So the period is how long it takes to complete one cycle. Okay, and we are finally on number 3. So why don't you hit pause, write down what the amplitude, frequency, and period is, and then see how you did. All right, so here, let's see, we have the amplitude is, well, we have a -2 in front of the word sine, but remember, the amplitude can never be negative. Amplitude represents the height of the curve from the midline. So height can never be negative. So the amplitude is always equal to the absolute value of what's here. Okay, it's always going to be the positive value of whatever number you see in front of the word sine or cosine. So here, the amplitude is going to be 2. Okay, the frequency is also 2, right? The frequency is the number in front of the x, or it's the number that comes after the word sine or cosine. So the frequency is also 2. And the period, again, we know we can't find the period by looking at the equation, but we do know that period is equal to 2 pi over the frequency. Okay, that's supposed to be an E. It's hard to write with these pens. But so 2 pi over, well, we know the frequency is 2. So these 2's will cancel off, leaving us with pi. So our period is pi, the frequency is 2, and the amplitude is also 2. Okay, now this is asking us to graph it from 0 to 2 pi. So we're just going to start numbering at 0 and go all the way out to 2 pi. All right, so at this point, you should be pretty familiar with how to number the x-axis. Right? We jump 2 boxes and label that pi over 2. Jump 2 more and label that pi. Jump 2 more and label that 3 pi over 2. And then finally 2 more, we have 2 pi. All right, so now, since our amplitude is 2, that's up to you if you just want to number 1, 2, or if you want to skip boxes, you could number this one and this 2. You could even, if you want, you could skip 3 boxes up and put a 1, and another 3 boxes and put a 2. Okay, that's up to you. I'm going to just skip a box and put 1, skip a box and put 2, and do the same thing in the negative direction. Okay, but that's your choice. All right, now let's think about if we're going to be graphing this. Now, our normal sine curve looks like this. But since we have a negative in front of it, doesn't that mean that we have to take this curve and basically you're going to reflect over the x-axis? So what does that mean? What that means is instead of starting at the midline and going up to your maximum, what we're going to do instead, let me do it over here, is we're going to start at our midline and we're going to go down to the minimum and then come back up and then back to the midline. Okay, so it's basically what we did was we took this and we flipped it, okay? And what I mean by that is we reflected it over the x-axis. Okay, so where we would have originally had a maximum, we now have a minimum. And where we originally would have had a minimum, we have a maximum. Okay, so I'm going to get rid of this one because we're not using that. All right, so here's our negative sine curve. Okay, right over here, negative sine curve. Now, we said the amplitude is 2, so we know we're going to go up to a maximum of 2 and a minimum of -2. And if the frequency is 2, what that means is we're fitting 2 complete curves between 0 and 2 pi. So this is only one sine curve. What we're going to be doing is we're going to fit a whole nother curve. Let me make this longer. We're going to fit a whole nother sine curve. So there we go, okay? We have one sine curve and another sine curve. And the frequency is how many sine curves or how many curves you're going to fit between 0 and 2 pi. So if this is 0, all the way over here is going to be 2 pi. Okay, so it takes us 2 pi units to fit 2 sine curves. All right, so let's think about this. So if we wanted to figure out how long it would take to complete one sine curve, well, this should be halfway between 0 and 2 pi. So what's halfway between 0 and 2 pi? Well, pi. Pi is halfway between 0 and 2 pi. So this occurs after pi units. Okay, and just to remind you, that's what our period is. Our period is how long it takes to fit one cycle. So we could see it takes pi units to fit one cycle. Okay, now I'm going to start graphing this up here. So we know how a sine curve works is the sine curve starts at a height of 0 and ends at a height of 0. Okay, so that being said, I'm going to put a point at 0, 0. There's the start of my first sine curve. And then that sine curve, that cycle is going to end also at a height of 0, right? So it's starting at a height of 0 and ending at a height of 0. And then halfway between them, aren't we also at a height of 0? So halfway between 0 and pi would be at pi over 2, right? Halfway between 0 and pi would be at pi over 2. So at pi over 2, we are also going to be at a height of 0. Now, since this is a negative sine curve, halfway between these first 2 points, we are going to be down at a minimum. Okay, we're going to be down here at a minimum. And that's why I like to skip boxes. Okay, because we skipped a box, we don't have to be in the middle of a box. Halfway between these 2 boxes is right there. We're going to take that down to -2 and plot a minimum point. Now, halfway between these 2 points, right? Halfway between these 2 points, aren't we going to be up at a maximum? So halfway between pi over 2 and a pi, so at this box right here, we're going to be up at a maximum of +2. Okay, so now I'm going to connect these. It's kind of hard on this app, but I'll do my best. So there we go. You want to try to make it as curvy as possible. That was really bad. It should look more like this. I just was having a little trouble with my stylus here. All right, but anyway, now what we want to do is we also want to fit another complete cycle of the sine curve. Okay, so we know that it, again, starts at a height of 0 and ends at a height of 0. So at 2 pi, we're going to be back at 0. And then halfway between these 2 points, right? Halfway between these 2 points, we're again going to be at a height of 0. So at 3 pi over 2, we're going to be at 0. And you can really just follow the pattern of this graph, right? Halfway between these 2 points, aren't we going to be back down at a minimum? And then halfway between these 2 points, right here, we're going to be up at a maximum. Oop. And then we can just connect them. Okay, and remember, you want to try to make it curvy, okay? You want to make it as curvy as possible. Do not make it pointy. It should not be like pointy. Okay, it should be as curvy as possible. And then just label y equals -2 sine of 2x.